Welcome back to the Gentle Machine. I hope you're doing well. I hope you're doing just fine. Wherever you are, you don't need to arrive any further than you already have. You can let the day loosen its grip, just a little, as we talk softly and gently about technology. It can seem complex at times, simplistic at others, but nothing here needs your effort. You can just listen, let your mind soften, and let the rest take care of itself. And now we can begin. Many things around us move in patterns. The sun rises and it sets. The tide comes in and it goes out. Repetition creates rhythm, a steady, familiar beat. An algorithm is one of the simplest ideas in computing. It is a quiet idea, a gentle one. It is not a thing you can hold. It has no shape or weight, no place where it rests. You can't point to an algorithm inside a machine. An algorithm is a way forward, a set of steps, a quiet method for deciding what comes next. On its own, it does absolutely nothing. It exists as instructions written down in a language machines can follow, stored as patterns of data. And like so many of the systems within modern technology, it simply waits. When a computer runs, energy begins to move. Circuits open and close. Signals travel. And in that movement, the algorithm briefly takes form, not as an object, but as an action. Maybe it helps to think of it like this. The algorithm is the recipe. The code is the recipe written on the page. The computer is the kitchen. And the processor is the cook, patiently following each step. The recipe doesn't cook the meal by itself. It has no power on its own. Only when something follows it does anything happen. And when the motion stops, the algorithm returns to waiting and stillness. So, an algorithm is not a machine, and it is not intelligence. It is a set of steps, a path laid out in advance, Do this, then do this. Then check, then repeat. That is all an algorithm ever is, a simple loop, a patient circle. Algorithms begin with people. They are born from a human thought. Someone decides the steps, carefully and thoughtfully. Someone defines what should be checked and what happens next. Once set in motion, the algorithm does not improvise. It does not wander. It follows the pattern it was given. What gives algorithms their power is repetition. A simple thing, done many times. The same steps, carried out again and again, without impatience. Without distraction or fatigue. Over time, this repetition creates stability. A gentle humming in the background of things. Algorithms do not rush. They wait for input. They don't observe the world continuously. They look, then they stop, then they look again. This is called sampling. At a set interval, the algorithm checks the state of things. Then it rests. Nothing happens in between. The world may change during that pause, but the algorithm will not notice until the next moment arrives. This is where rhythm comes from. Not speed, but timing. It is the rhythm of waiting and the rhythm of acting. An algorithm that samples too often becomes nervous, noisy, and reactive. One that samples too slowly becomes distant and unresponsive. So the interval matters, and it is chosen carefully. How often should I look? How long can I wait? Between each check, the algorithm is not watching. It is waiting and holding. This creates a pulse, and over time, the pulse becomes a steady presence. Not alert or asleep, just attentive enough. An algorithm's quiet strength comes from limitation. It does not try to see everything, for it cannot. So, it chooses what to ignore. This choice is decided long before the algorithm ever runs. A human decides which details matter and which ones can be left out. Everything outside that narrow focus simply does not exist to the system. This is how the algorithm stays calm. By reducing the world to a small, manageable slice, it can respond steadily and consistently. It never feels overwhelmed by complexity, because complexity has already been filtered away. What remains is a simpler landscape, one it can move through again and again. This is why algorithms often feel blunt or too literal. They are not seeing less because they are careless. They are seeing less because they were designed to. Attention for an algorithm is a resource. It is spent carefully. By choosing not to notice most of the world, it becomes very good at noticing one thing. Every algorithm lives inside a simple structure. Something comes in, rules are applied, something comes out. This pattern never changes. The input might be a number, a signal, a measurement, a moment in time. The rules decide what to do with it, not why or whether it matters, just how it should be handled. And the output is the result of that check. Sometimes the output is a visible one, a change, a decision, a shift. But very often, the output is simply to continue. Nothing changes. Everything remains as it was. This is still an output. The input arrives, the rules are checked, and the result is confirmation that no response is needed. This is important. Algorithms are not constantly acting, they are constantly evaluating. Action is rare, while checking is constant. This is why they feel quiet. They are always ready, but seldom moved. When an output does occur, it is not because the algorithm decided to intervene. It is because the rules allowed it. Consider, if you will, a complex algorithm at work in the background of a city. Traffic lights, for example, guiding the flow so gently. No single traffic light knows where anyone is going. It does not see the whole city, it does not plan. Instead, it follows a rhythm. It watches how long cars wait. It measures how often a road fills and adjusts timing slightly. Then it checks again, green, pause, red, pause. Across the city, thousands of these small decisions repeat. Not in conversation, but in coordination. But it is simply rhythm, maintained over time. Other algorithms work with information instead of roads, quietly sorting the world's library. When people talk about algorithms in everyday life, they are often talking about suggestion. The lists that appear on a screen, the next video, the recommended film, the quiet nudge towards something else. These algorithms do not know what you want. They do not understand taste or mood or meaning. They only observe patterns. What you watch and what you finish. What you pause and what you skip. From this they make a simple guess. Not about who you are, but about what might keep the rhythm going. If this happened, then perhaps this will follow. They arrange possibilities rather than choosing specific content. Millions of small signals are compared, grouped, and gently sorted. Not to persuade, but to reduce uncertainty. And the world contains too much to show all at once. So the algorithm narrows the field, offering a path based on what has come before. And if the guess is wrong, nothing is lost. The system adjusts. The pattern shifts. These algorithms are not watching you. They are watching movement. Trying again and again to keep things flowing. Search engines, for instance, rely on many algorithms working together. Each one follows its own steps. Some sort, some compare, some measure relevance, while others repeat checks over time. None of them understand meaning. They only recognize patterns. The rhythm comes from constant checking, compare, adjust, repeat. As information changes, the rhythm shifts. When things stabilize, it slows. Algorithms do not learn in the human sense. They do not have memories or insights. They adjust, like a plant turning its leaves toward the sun. They notice differences, they change parameters, then return to repeating. Back to the simple, patient loop. Like a thermostat, feeling the air, making a small change. Like a tide, responding in a rhythm that spans centuries. Like breathing, in and out, without a single thought. This adjustment is not ambition, it is responsiveness. The simple act of staying in balance with the world. Algorithms are especially useful when the world changes gradually. They are good at smoothing, at keeping systems from swinging too far in any direction. They work best when their rhythm matches the pace of the environment around them. Many algorithms run while we are not paying attention. Their work is invisible and silent. They balance electrical grids. They manage network traffic. They organize information. They reduce waste. They are the quiet caretakers of our complex world. At night, many algorithms slow. Their rhythm changes with the setting of the sun. They check less often. They wait longer between cycles. They allow systems to rest. The rhythm softens, like a sleeping breath. Nothing important is lost. The pattern remains. It is just waiting for morning. Algorithms do not seek an ending. They do not aim for completion. They are content to continue. The cycle is their purpose. In this way, algorithms are engines of steadiness. Patterns that hold, foundations that are stable. And while they continue, there is nothing we need to do. No need to worry. No need to watch over them. The rhythm is already in place, and we can rest within it. And you can rest too. Quietly, steadily, all through the night. And that's where we'll leave it for now. the patterns will continue arranging themselves, whether we notice them or not. The systems will keep doing what they were designed to do, without intention or opinion. Thank you for spending this time here. Thank you for staying with the invisible movements that shape the surface of things. The gentle machine will be back to speak to you soon. And everything will unfold as it should. Until we meet again, take care.